On the night of October 19th, 2017, a telescope on the summit of a dormant Hawaiian volcano recorded a faint smear of light drifting against the fixed stars. It was unremarkable. A few pixels, sliding a fraction of a degree per hour. The software that flagged it had been built to hunt asteroids that might one day threaten Earth, and by every early measurement, this was another rock. Then the orbit came back. The object was not circling the sun, it was falling through it, on an open, hyperbolic path that could only mean one thing. It had not formed here. It had entered our solar system from the darkness between the stars, and within weeks it would be gone forever, back into a night it had been crossing for possibly hundreds of millions of years. Astronomers named it Oumuamua, a scout, a messenger arriving first. And almost immediately it began doing something no one could explain. Astronomers had expected this moment for decades. When young stars build their worlds, gravitational chaos flings enormous quantities of leftover debris out of the system entirely. Multiply that by every star in the galaxy, and the space between them should be crowded with wanderers. So the expectation for the first one was simple. It would be a comet, a dirty ice body that, warmed by a star, bleeds gas and dust into a glowing tail. And that tail is not decoration. It is an engine. Escaping gas pushes the nucleus off a purely gravitational path, a nudge astronomers have measured for over a century, and call non-gravitational acceleration. Oumuamua should have been an easy case. It wasn't. And the first strange thing about it was something you could almost watch happen. Over roughly 8 hours, that single point of light climbed from barely detectable to 10 times brighter, then collapsed back into near invisibility. A slow, hypnotic pulse like something enormously long turning end over end in the dark. Brightness like that is a shadow puppet. It tells you shape. A tumbling body throws back more light when its broad side faces us, less when it turns edge on. A tenfold swing meant a body perhaps 5 to 10 times longer than it was wide. Among the millions of objects cataloged in our solar system, nothing looks like that. But the brightness wasn't the real mystery. Astronomers went looking for the tail and found empty space. The Spitzer Space Telescope stared at it in infrared, hunting the warm glow of escaping dust. Nothing. No coma, no dust, no gas. By every observational standard available, this was not a comet. Then Hubble detected something that changed everything. Tracking Oumuamua as it fled the solar system, an international team found the object was speeding up, not from gravity. Something was pushing it outward from the sun, a steady force, fading with distance, exactly the way a comet's engine behaves, so it moved like a comet, but it showed none of a comet's evidence. Hold that contradiction, because everything that follows is an attempt to break it. And remember what was at stake. This was humanity's first known visitor from another star system, and we had a matter of weeks to understand it before it disappeared beyond the reach of every telescope on Earth, permanently. There would be no second look. Whatever we failed to measure, we would never measure. What followed was less a debate than an elimination. The first suspect was instrument error, a calibration fault, a modeling mistake, an artifact in the astrometry. It died fast. Multiple observatories on separate continents, using independent detectors and independent software, produced the same trajectory and the same acceleration. The signal was real. The second suspect was ordinary water ice outgassing, the textbook answer, the one every astronomer wanted. But water sublimation cannot happen quietly. It drags dust with it, and that dust glows in infrared. Spitzer's non-detection was deep and specific. The textbook answer could not produce the observed push without leaving a trace we should have seen. The third suspect was sunlight itself. Photons carry momentum, and a thin enough object can be pushed by starlight. The principle behind solar sails. The fit to the acceleration curve was startlingly good. But the price was steep, a density so low and a structure so thin that nothing in our experience comes close. Avi Loeb and Shmuel Bayali of Harvard argued that if natural explanations failed, an artificial origin deserved serious consideration. The paper was peer-reviewed and fiercely contested. It was never disproven. It was simply never necessary. The fourth suspect tried to make that same physics natural. A fractal dust aggregate, a structure 100 times more porous than snow, buildable without engineers. Elegant, but a body like that should be common in the galaxy, and nothing else remotely like it had ever been observed. The fifth was stranger still. A shard of solid nitrogen ice chipped off a distant exopluto, eroding invisibly into its cigar shape as it fell inward. It explained the silence beautifully. It also required a specific, fragile chain of events, and enough shattered ice worlds to make such fragments plentiful. Every theory seemed convincing, until one question destroyed it. Each explained the push, or the shape, or the silence. None explained all three without inventing something the universe had never shown us before. For nearly 5 years, the contradiction refused to disappear. Then the answer arrived, and it wasn't exotic at all. In March 2023, Jennifer Bergner and Daryl Seligman proposed a mechanism requiring nothing unusual, only an ordinary comet and an extraordinarily long journey. For millions of years in interstellar space, cosmic radiation hammers water ice. That radiation splits water molecules apart, and the molecular hydrogen it creates gets trapped inside the ice's crystal structure. It doesn't escape, it builds. Then the object nears a star. The ice warms, the structure reorganizes, and all that stored hydrogen floods outward. Here is why it resolves everything. Molecular hydrogen is the lightest substance in existence. A minuscule mass, escaping fast, delivers exactly the measured push, while lifting almost no dust and emitting essentially nothing Spitzer was designed to see. The engine was always running. It was simply invisible. The hypothesis has support, and it has critics. Some researchers still question whether enough hydrogen can realistically be stored and released. It is the leading natural explanation. It is not a closed case. But the real revelation was never about Oumuamua. 2 years after it left, a second interstellar object arrived. I/Borisov, and it was completely, boringly normal. An obvious comet with an obvious tail. In 2025, a third was confirmed. These visitors were never rare. Our instruments had simply never been good enough to catch them. That reframes the entire story. If Oumuamua behaved strangely because of radiation processing over millions of years of interstellar exposure, then that processing isn't an anomaly. It is the default condition of matter in this galaxy. Every wandering fragment out there is being chemically rewritten in the dark. And the same radiation chemistry that builds hidden hydrogen reservoirs also builds the organic molecules that come before biology. We thought we were studying a visitor. We were being shown a process running everywhere, constantly unobserved. Sit with what that took. For 8 years, some of the sharpest minds in astronomy argued over an object they never once saw as more than a point of light, that they watched for a few weeks, and that will never come back. They had a trajectory and a flicker. From that, they reconstructed a chemical history older than our species. The universe never announced itself. It passed through briefly, and left the faintest possible trace. A messenger arrived from another star. The message was never where it came from. It was what it revealed about everything still out there, moving quietly in the dark, waiting for us to become the kind of observers who notice. If you're fascinated by the universe's greatest mysteries, subscribe and join us as we investigate the discoveries that continue to change what we know about space.